Mr. Right here, and welcome to this film in which we're running through some Edexcel IGCSE questions which involve the sine rule, the cosine rule, and also the formula for the area of a triangle, which you have also covered when you've been looking at sine rule and cosine rule. That is that the area of a triangle is a half AB sine C. Now, I've tried to put these questions in order of difficulty. You can download the questions by hitting the link in the description. There are 8 in all. As we get to the end of these questions, they're really quite feisty, and most of these questions are 5 or 6 markers, and the examiners make you work for your money. I suggest you download the questions, have a shot at them, and then watch me do them, or watch the film as you're working on the questions and work alongside me. Up to you. Good luck. Let me know in the comments how you get on. If you've got any questions or you'd like me to explain anything again or even explain anything better, then ask me in the comments and of course I'll respond. Right, on you get with the maths. Question 1. Right, a triangle has sides 8, 10 and 14. Work out the size of the largest angle. Give your answer correct to one decimal place. Right, let's draw a sketch of that triangle, shall we? Let's draw the long side here, 14. Right, then we're going to have a side that is 8. Maybe it's going to look like that. And a side which is 10. Now I'm being asked to find the size of the largest angle. So that's going to be this angle here, the angle that's opposite the longest side. I'm going to call that A. So I've got B and C. Okay, I've got little side, side little a, side little b, side little c. Now, I haven't got a right angle here, so I'm not going to be able to use SOHCAHTOA. So I've got a triangle here, and I know all 3 sides. So I'm going to use the cosine rule, because if you know all 3 sides, you can use the cosine rule. Now, in this case, I'm finding an angle. So I'm going to use my rearranged cosine rule, which is cos A equals b squared plus c squared minus a squared over 2bc. So in my case, this is going to be 10 squared plus 8 squared minus 14 squared over 2 times 10 times 8. So that tells me that cos A, if I do a bit of work on my calculator, is minus a fifth. Shift cos that, inverse cos that, tells you that A is 101 degrees, 0.53, and so on, and we're asked for the answer to one decimal place. So the answer I'm going to give is 101.5. And that is question 1. We used the cosine rule because we knew all 3 sides. Question 2. The diagram shows triangle PQR. Okay, I can see I've got 2 sides there, and the included angle. Okay, 2 sides and the angle between those 2 sides. I'm being asked to calculate the length of PR. Now I see that this angle here is called big Q, so I'm going to call QR little q. Right, so I've got to find little q there. Now, as we've already said, we're given 2 sides and the included angle. So we're going to use the cosine rule. And that is going to be that q squared equals the square of each of the other sides minus twice 17.8 times 26.3 times cos 36. So this gives me an expression that I can stick into my calculator to tell me what q squared is. Q squared is 251 point all sorts of digits. So if I square root that, I find that q is 15.844 and so on, which to 3 significant figures is 15.8. And in that case, I use the cosine rule again because I had 2 sides and the included angle. And let's just have a look. That question is a question 18, so it's towards the end of the paper, so they consider that to be quite difficult. Okay, question 3. I've got a triangle here, and I've got AB is 4.6, BC is 8.3 and angle ABC is acute. All of those are as on the diagram. And I'm told here that the area of the triangle ABC is 12 centimetres. That immediately makes me think that we might be using the area formula, that the area is a half AB sine C, which of course is on the top of the paper. Right, question is, work out the perimeter of triangle ABC. Give your answer correct to 3 significant figures. So if we're working out the perimeter, we're going to want to know the length around the shape. 8.3 plus 4.6 plus that length AC. So really, this question is about finding that length AC. I'm going to call that length little b because it's the side opposite the angle capital B. All right, now if I knew this angle here, which I'll call alpha, then of course I could simply use the cosine rule, because b squared would be a squared plus c squared minus 2ac times cos the angle in between. But I don't know that angle at B, which I've marked alpha. So the first thing I'm going to do is to find that angle. And to find the angle, I'm going to use this fact here. The area of the triangle is 12 square centimetres. So 12 is going to equal, looking at this formula, a half times these two side lengths multiplied by sine the angle in between those two sides. So half times 8.3 multiplied by 4.6 multiplied by sine the angle, I don't know, sine alpha. Okay, well here's an equation I can solve to find alpha. So 12 is going to be a half times 4.6 times 8.3, 19.09 multiplied by sine alpha. Brilliant. So sine alpha, dividing both sides by 19.09 is 12 divided by 19.09, and if I put that into my calculator and inverse sine it, shift sine, then I find that that angle alpha is 38.947, and so on. Good. Right, I know that angle alpha there is 38.9. And now I'm in a position to use the cosine rule to find the side little b. Little b squared is going to be 4.6 squared plus 8.3 squared minus 2 times 4.6 times 8.3 multiplied by cos 38.9. Use the whole number on your calculator, of course. So that tells me that b squared is equal to a bit of calculator use, and you should get 30.6627 and so on and so forth. And square root that, and you'll have b is 5.53739 and so on. So that's that length found. Good. So now I'm in a position to answer the question, because the question was work out the perimeter of the triangle. So the perimeter of the triangle is going to be the length of B, 5.537, and so on, plus 8.3, plus 4.6, which gives me a perimeter of 18.437, and so on, which to 3 significant figures is 18.4 centimetres. And that is question 3 complete. Okay, question 4. The diagram shows the positions of 3 ships A, B, and C. Yes, it does. Ship B is due north of ship A. Yes, that's how it looks on the diagram. The bearing of ship C from ship A is 120. There you are. That's labelled on the diagram. Calculate the bearing of ship C from ship B. So I'm being asked to calculate that angle there, which I'll call alpha. Give your answer correct to the nearest degree. Okay, well the first thing to do, of course, is to make a plan. If it's alpha that I want to find, then it would be quite nice to find that angle there, which I'll call angle B. It's already called angle B, I suppose, that angle, because then I can do 180 minus that red angle to get alpha. So how can I find that red angle? Well, I could use the sine rule. I've got that and that and that and I don't have that, do I? The side which is opposite angle A. But I'm wondering if I couldn't find the side that's opposite A, and then I could use the sine rule. So can I find this side, little a? Well, the answer is I can, because I've got the other two sides and the included angle there. So that means that I can use the cosine rule. So I know that a squared is going to equal 150 squared plus 275 squared minus 2 times 150 times 275 times cos the included angle, cos 120. So I can evaluate that on my calculator, and that tells me that a squared is 139,375 point so on and so forth. And so if I square root that, that tells me that a is 373.329 and so on. So now I know what A is there. So I can label that 373. Now I think that I can find B, because I've got the side and the angle opposite it, and the side, and I'll find this angle here opposite that side. Great. So sine rule, here we go. So I'm looking to find the angle B, so it's going to be sine B over the opposite side equals sine 120 over its opposite side. Okay, so that tells me that sine of B is sine 120 divided by 373.329 and so on equals times by 275, which tells me that sine B is 0.637 and so on. So inverse sine that tells me that angle B is 39.637. Okay, so now I know this red angle here, which means that I can find alpha, because alpha will just be 180 minus that angle B, which gives me 140.36 and so on. And I'm asked to give the bearing correct to the nearest degree, 140, and it's already got three figures, look. Okay, so that was a question that involved using the cosine rule to find this side, and then the sine rule to find this angle, and then I did 180 minus that to get the bearing. Okay, so that is worth 5 marks, that question, and it's a question 16, so 5 marks there in your IGCSE. Okay, question 5. Here is a triangle ABC. Yes, it is. Calculate the value of x. Right, let's just make sure I see what I've been given. I've got a side and the included angle. So I could use the cosine rule there to find this side, which is side little b. Okay, so that might be useful. What else have I got? I've got this angle x. Well, if I found the side b here, then I would have all three sides of the triangle. So I could use the cosine rule to find little x, or the sine rule to find little x, because I'd have that side and the opposite, and I'd have the opposite and x. Okay, so lots of options here. What I'm going to start by doing is I'm going to start by using the cosine rule to find that side b. So b squared is going to be 4.1 squared plus 5.3 squared minus 2 times 4.1 times 5.3 times cos the angle in the middle, cos 110. So using my calculator, I can tell you that b squared is equal to 59.76, square root that, and b is equal to 7.73, and so on. So this side here is equal to 7.73. Now I'm asked to find angle x, so there are probably a couple of ways I can do this. I've got x on the opposite side, and I've got 110 on the opposite side. So I'm going to use the sine rule. Now I'm looking to find x, so I'm going to put sine x on the top. So sine x over 5.3, the opposite side, is going to be sine 110 divided by its opposite side, 7.73. That tells me that sine x is sine 110 divided by 7.73 multiplied by 5.3. Okay, well that equals 0.644 and so on. So then I simply inverse sine that to tell me that x is 107 and so on. Now I'm asked to give my answer correct to three significant figures. So the answer I'm going to give is 40.1. So in that question, we used the cosine rule to find the missing side, which enabled us to use the sine rule to find x. And that question is worth 5 marks again, crikey. They are worth a lot of marks, these sine rule and cosine rule questions. And that's the end of question 5. Question 6. The diagram shows a quadrilateral A, B, C, D. Let's just have a look. A, B, C, D. Yes, it does. There's the quadrilateral. Okay. The angle BCD, this angle is acute. Well, it's drawn acute, so that's looking good. Given that the area of the triangle BCD is 405 square centimetres. Right, so just a minute. I'm going to be using the area formula, I reckon. So I'm going to be using the formula. The area is a half AB sine C, sine the angle in between A and B. All right, so back to the question. Given that the area of BCD is 405 square centimetres, work out the size of angle ABD. ABD. That's this angle, isn't it? The angle there at B. Okay. Well, the first thing to do is to make a plan. Now, if I want to find that angle there, I could find that angle if I had all three sides of the triangle, because then I could use the cosine rule. So I'm wondering if there's a way to find this side here, which I'll call little a. If there was a way of finding that side, then I'd be all right, wouldn't I? So, just a minute. We're told the area of triangle BCD, aren't we? BCD, we know the area of that triangle there. So the area of that triangle is 405. So I've got 405 equals a half AB sine C. That's going to mean I can find this angle here. Right, so let's use the area of the triangle to find that angle there. A half times 45 times 36 times sine C. Okay, so that means, when I've finished fiddling around with that, that 810 sine C equals 405. Divide both sides by 810. Sine C is a half. Inverse sine tells me that C is 30. Okay, so now I know that this angle is 30. That means that I can find this side using the cosine rule, because I've got two sides and the angle in between them. Brilliant. So a squared will be 45 squared plus 36 squared minus 2 times 45 times 36 times cos 30. Okay, well, on my calculator, that tells me that a squared is 515 point lots of digits. Square root that, and a is 22.695, and so on. Now, I've got this side now is 22 0.695. And now on that left-hand triangle, I can use the cosine rule because I've got three sides there. Okay, so I know that cos b, if I use the cosine rule rearranged, cos b will be, that's going to be that squared and that squared minus that squared. Right, so it's going to be 19 squared plus 22.695 squared minus 28 squared all over 2 times 19 times 28. So that tells me that cos b is 0.08 and so on. Inverse cos tells you that b is 85.035 and so on. And I'm asked to one decimal place, so the answer I'm going to give is 85.0. And that is question 6 done. Crikey, look at that. We needed the area formula, and we used the cosine rule both ways around. Okay, well, 5 marks again, and a question 16. So quite a hard question, and worth 5 marks. Okay, question 7. Right, so ABCD is a quadrilateral. Let's have a look. ABCD, yes, ABCD is a quadrilateral. It's the whole thing. The area of ACD, so that's the area of this bit here, is 250. Now I'm tempted just to go ahead and use that fact along with the area formula. But I think what we should do is read the rest of the question first. The question is, calculate the area of the quadrilateral ABCD. So it wants us to work out the area of the whole thing. Show you're working clearly. Give your answer to 3 significant figures. Right, well, I already know the area of the left-hand side. So I'm guessing the project really is to find this black area there, the area of that triangle on the left, the triangle ABC. Now to find the area of triangle ABC, I'm assuming I'm going to use this formula, that the area is a half AB sine C. So I'm going to need one angle and the 2 sides which are alongside it. Okay. Well, let's just have a look and see what we can do. If I've got the area of this left-hand triangle here, this one that I've done in blue, then I'm thinking I can find this side, because I've got that side and the angle and then that side. So I'm going to rub out everything else, and I'm simply going to concentrate on the left-hand triangle. I'm going to call this side D here. And I know that the area of that left-hand triangle is going to be a half times 26 times d times sine 39. And I know that that equals 250. So I've got a little equation here. I've got 13d times sine 39 equals 250. So that tells me that d is 250 divided by 13 times sine 39. Okay. So that mystery side there, that D, is 30.557. Okay, good. Right, well done. We found that side. 30.557. Now, all eyes on the left-hand triangle now. How can we find the area of that? I really want to have 2 sides and an enclosed angle so that I can use the formula. Well, I can work out this angle, of course. That's just 180 minus 95 minus 47. So that angle at the top there is 38. Okay. So now, look at this, I can use the sine rule. I've got that side on the opposite angle, okay, and I've got this angle, so why not use that to find this side here. Because then I'll have two sides and the enclosed angle, the 47. So I'll be able to use the area formula. So I'm going to call this side here little a, and I'm going to use the sine rule. So I'm going to have a over sine 38, a over sine the angle opposite, and that's going to equal 30.557 over sine the opposite angle that, the angle opposite that, which is sine 95. So that tells me that a is 30.557 divided by sine 95 equals times by sine 38. So a is 18.884. Okay. 18.884. Now I can find the area of that left-hand triangle because I've got side, side, and angle in the middle. Brilliant. So the area will be a half times A times B, the two sides that I have, times sine the angle between them, sine 47. Right, bit of calculator work tells me that the area of that left-hand triangle is 211.01. Now the question, of course, was to calculate the area of the whole thing. So the whole thing, the area of the quadrilateral A, B, C, and D is going to be the area of the left-hand triangle plus the area of the right-hand triangle. 461.01 and so on, and I'm asked to give it correct to three significant figures, so it's going to be 4.61. Now that is a feisty question there. Look at that, it's worth 6 marks. Well, of course it's feisty if it's worth 6 marks. Okay, and there were 3 or 4 definite stages there. Question 8. Right, we've got a shape formed from 2 triangles. Yes, I can see that. Okay, ACD is a straight line. Yep, that's drawn as a straight line. And BCE, yep, that's a straight line. Okay, and then I've got these lengths, all of which are labelled on the diagram, and that angle, which is also labelled on the diagram. And I'm asked to work out the length of DE. That's this length here. Okay, so let's make a plan. Now, looking at the right-hand triangle, if I knew this angle here, this red angle, then I could find x using the cosine rule because I'd have the two sides and the included angle. So, how can I find that red angle? Well, that red angle is equal to this blue angle, isn't it? So maybe I should be asking myself, how can I find the blue angle? Well, I could find the blue angle by doing 180 minus 64 and this black angle. So maybe I have to ask myself, can I find that black angle? And the answer is, you definitely can find that black angle because you've got 31 and the angle opposite that side. You've got 24, and that will enable you to find the black angle. So I'm going to find the black angle using the sine rule. And then I'm going to do 180 minus the black angle minus 64 to find the blue angle. That's going to tell me the red angle, and then I can use the cosine rule in the right-hand triangle to find the length of x. So there's my plan. So let's start off by finding this black angle, the angle B. So looking at that left-hand triangle, sine the angle I want to know, divided by the opposite side, is going to equal sine 64 divided by its opposite side. So that tells me that sine B will be sine 64 divided by 31 equals times by 24, 0.69, and so on. Inverse sine that gives you B is 44.09. Great. Now find the blue angle. Well, the blue angle is going to be 180 minus 64 minus 44.09. So that blue angle is 71.91. Great. Now use the cosine rule to find x. Well, the red angle, first of all, is going to be 79.91 because it's vertically opposite the blue angle. So now, x squared equals 16 squared plus 19 squared minus 2 times 16 times 19 times cos the angle in between them. All right, now, bit of work on your calculator, and you'll find that x squared is 428.20, and so on. Square root that, and you get x is 20.693, and so on. So that's the length of DE, but we're asked to give it correct to 3 significant figures, so I would give the answer 20.7. And that is question 8 finished. Now, how many marks is that? 5 marks again. Crikey. Right, and that is the end of these questions. Mr. Right here, and well done for making it through to the end. Some of those questions towards the end are very definite grade 8 stroke grade 9 questions, so well done if you scored on those. Any questions? Leave me a comment and I'll respond. If you'd like any help with anything else, leave me a comment and I'll respond. If you found the film useful, please hit like, give me some positive feedback, and let other people know of the channel. And of course, if you're preparing for your Edexcel IGCSE Maths exams, do subscribe to the channel. There is lots more there to help you. Right, thanks for watching. See you in the next film.